Hey guys, I hope you're doing well. I'm back with another tutorial, like always. In this video, we are going to study how much lift this simple UAV model is going to produce, and also how many newtons of drag is it gonna face in certain speeds. This is a simple technique in order to understand what kind of electric motor or internal combustion engine is necessary to be mounted on this model to achieve an acceptable flight. So, yeah, so please leave a like, share, and subscribe on my channel to support my content and me. Guys, really, I need your support. So, as you can see, this is one of my old designs. So first of all, we need to go to the flow simulation tab. Of course, if it's not saved, save your design because it's necessary to do the flow simulation study. And we are going through the wizard, and I'm gonna name this project as 250, I'm sorry, kilometers per hour. So yeah, as you can see, my model is going to be studied on SI system, very basic, and I need to change my velocity to kilometers per hour, and we need to change the gravity to the direction that, well, we figure it as the ground. So as you can see, it is pretty much correct, and we need to add fluid. So this is an UAV. We need to choose air and add it to project fluids. So this is the important part. We need to add a speed in direction which our model is going to fly. In this particular model, it is y-axis, as you can see. So I'm going to add 250 kilometers an hour. So as you can see, the fluid direction or air direction is going to be shown here, and it is pretty much correct. And we will click finish. So our study is almost ready. So we need to add goals from this section, insert global goals. And what we need to understand from this particular model, we need to understand the velocity, which is in y direction. I'm going to average it. And also the force based on newtons. So drag is going to be against the direction of flight. So it is y-axis, and lift is going to be z-axis, as you can see. So we need to click on z-axis. There are a lot of options that you can actually do the study on your model, but for this particular tutorial, we need to have these three options. So we click and it is pretty much ready, and we are going to run the study and wait for the results. So yeah. All right, as you can see, average velocity is to almost 250 kilometers an hour. All right, guys, as you can see, the study is finished, and we have our velocity here, 250 kilometers an hour, and our model is facing with 35 newtons of drag, and it produces 36 newtons of lift. So as you can see here, we are going to click on results in order to have a flow trajectories on our model. And you, well, basically you can use pipes, lines, and etc. My favorite one is arrows flat, and I'm going to choose every single face on my model here, and hit the OK. So we have a simple vision of how the flow rate works around our model. This actually shows us the airflow around this UAV, and we can actually play this as an animation. You can basically have vision on vortex area, how the vortex generate is going to generate by this wingtips, and also have a vision of airflow. So I'm going to stop the animation and hide flow trajectories, and I'm going to insert surface plots in order to see the areas with high pressure and low pressure airflows. Hit the OK. So as you can see, these blue areas are low pressure areas and the green ones are high pressure area. And that's it. That's it for this tutorial. Please leave a like, share, and subscribe to my channel.